Welcome everybody. This is our fourth session in NEET previous year questions for chapter Alternating Current of class 12th. Before this video, we have made 3 videos in this series and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for JEE previous year's questions. So if some of your friends are preparing for JEE or if you want some additional practice, then you can watch those videos also. And if you find these videos useful, helpful, then do press the like button, share them and subscribe to our channel. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. In the previous one, we were around somewhat 30. So 34, 35 is complete. So we will start with 36 today. Let me adjust pen thickness slightly. So here we have LCR circuit, and that is a series LCR circuit. Power loss at resonance we have to find out. So at resonance, we know normal power loss is given by Vi into cos phi. Now this cos phi is equal to R by Z, and Z is equal to R square plus Xc minus XL square. At resonance, Xc and XL are equal, so R is equal to Z. So cos phi is equal to 1, or in short, power is equal to Vi. And we can write it like either I square times R or V square divided by R. So option C matches with the answer. So option C will be the right answer here. Let's move to the next one. A step-up transformer is connected to AC mains of supply 220 volt operating at, so input is 220 and operate at 11,000 volt 88 watts. The current in the secondary circuit ignoring the power loss. So here it is mentioned that power loss, we have to ignore the power loss, and if we ignore the power loss means input power and output power are equal, or we can say coefficient of performance or efficiency is 1, and that is equal to P out by P in. So if it is 1, so P input is equal to P output, and power is potential multiplies the current. So here we have, I think here we have to find the output current. We can say the current in the secondary circuit. So we have to find out the current in the secondary circuit, and this is inputs, we can say input potential, and this is output potential, and we have been given 88 watts of power. So that must be input power, only then this will be possible to solve the question. So input power is 88 volt, output power, that will be voltage time current, voltage output voltage is 11,000 and into secondary current over the output current. So IS will be 88 by 11,000, so 8 by 1000 or 8 milliampere. That will be the answer here, option A. Here statement is slightly confusing. It should be written like that, AC means 220 volts, comma 88 watt. This 88 watt should be here, not in the beside of 11,000 volts. So moving to the next one. In an ideal transformer, turn ratio is given. The ratio of the Vs to Vp is equal to, where symbols carry their usual meaning. So we have to find voltage ratio, and we know that turns multiplied by the voltage or ratio of voltage per turn is equal, means primary voltage by the number of turns in the primary coil is equal to secondary voltage by the number of turns in the secondary voltage, means we can say voltage per unit turn is equal in both of the both of the coils in the primary and the secondary coil of the transformer. So we have NP and ratio of NP and NS. From this we can write Vp by Vs is equal to Np by Ns. That Np by Ns is half. So it is asked Vs by Vp. So Vs by Vp will be 2 or 2 ratio 1. Option A will be the right answer here. Now a 12 volt 60 watt lamp is connected to a secondary winding of a step down transformer. So we have primary winding. Suppose this is primary winding and this is secondary winding. And into this secondary winding, we have a lamp connected, and that lamp is of 60 watt. Power of that lamp is 60 watt, and potential required, the power measured at 12 volt. Now primary winding is connected to 220 volt and it should be AC, only then transformer operation is possible. The current in the primary, so we have to find the current in the primary. What we have to assume here, that there is no power loss until unless mentioned in the question. We assume that conditions are ideal and there is no power loss in the transformer, means input power is equal to output power. Now input power will be input current multiply the input voltage, so 220 into I is equal to output power. That output power is already given to us, that is 60. So input current will be 60 by 220 or 3 by 11. That will be 0.287, yes, 7.7 ampere, and it is option C for us. Let's move to the next one. A step down transformer connected to AC mains. Again, step down transformer, input 220, operate at 11 volt, 44 watt lamp, ignoring the power loss of the transformer. What is the current in the primary circuit? So again, as done in the previous one, that input power is equal to output power. Input power will be 220 times I, and output power is 44 watts. So I will be 44 by 220, or it will be 10 2.2 ampere. Option A is the right answer here. Next one, a transformer having efficiency of 90% is working on. So here in this question we have been given efficiency neta, that is 90%. So neta is 90% or 90 by 100, and that is P output by P input. So working on 200 volt 3 kilowatt power supply. If the current in the secondary coil is 6 ampere, voltage across the secondary coil and the current in the primary coil. So first let's check for the primary. For primary coil, we have 200 volt supply with 3 kilowatt power rating, and we know that power is equal to potential times current. So 3 kilowatt, 3 into 10 raised to power 3 should be equal to 200 into I. This current is for primary current, so IP. So solving this, we will get 3000 by 200. IP will be 15 ampere. So current in the primary coil or primary winding is 15 ampere. So we have three options with 50 ampere answer. Now coming to the output. Now output current is 6 ampere. So using this method, 9 by 10 is equal to P out. P out will be secondary voltage to secondary current, that is 6, by input power. Input power is 3 kilowatt. So 3000. 0 get cancelled. This will on 50 and Vs is 450 volts. So here it is, option B is the right answer here. Let's move to the next one. The primary winding of a transformer when connected to a DC battery of 100 volt draw a current of 1 milliampere. So we have a primary winding and we have a DC battery here. So potential is 10 volt and current flowing is 1 milliampere. The number of turns in the primary and secondary are 50 and 100. So here we have 50 turns and here we have secondary winding. It has 100 turns, so it will be slightly bigger. The voltage in the secondary circuit, respectively, voltage and current, we have to find out in the secondary one. So as we can see here that this is a DC source and transformer does not work on DC source. So 0 volt, therefore no current. Option C is the answer here. It is slightly tricky one. If this is a AC circuit, then we know that voltage per unit turn is equal. So in that case, 10 by 50 should be equal to Vs by 100, and from that secondary voltage is 20, and then we can compare their powers, and from that we calculate the current. But as this is a DC source, so there will be no transformer will not work, and there will be no current or voltage in the secondary coil. Let's move to the next one. A 220 input is supplied to a transformer. Output circuit draws a current 2 ampere at 440 volt. Efficiency is 80%. The current drawn by the primary winding. So we have to find out the current in the input winding or primary winding. As efficiency is 80, so neta is 80 by 100. That is output power by input power, and output power is output current times output potential, that is 2 into 440 divided by input current by input potential. Input current we don't know, that's I primary, and input potential is 220. So this is on 2. So we can say 8 by 10 is equal to 4 by IP, and this will go on 2, this will go on 5. So from this, IP is 5 ampere. Option D is the right answer here. Let's move to the next one. The primary and secondary coil of a transformer have 50 and 1500 turns respectively. Magnetic flux linked with the primary coil is given by phi is equal to phi V plus 40, where phi is in Weber, T is in second, and phi V is a constant. So phi V is constant. Voltage, output voltage across the secondary voltage we have to find out. Secondary coil we have to find out. So we know that in the secondary coil, voltage is induced due to induced EMF, or there is change in flux. So that due to that there is induced EMF, and induced EMF is given by negative of d phi by dt. So negative of d by dt of phi v plus 4t will give us, as phi v is constant, that will give us minus 4. So this will be the induced EMF. We ignore the negative sign here, see, because it just represents the direction. Now this flux is linked with the primary coil. So we can say voltage of the primary coil is 4, and we have to find voltage across secondary coil, and we know that voltage per unit turn is equal. So Vs by Ns is equal to Vp by Np, and from this secondary voltage will be Ns by Np into Vp. Number of turns in secondary are 1500 divided by 50 into 4. So this will go on 30. So 30 multiply 4, that will be 120 volts. Option A will be the right answer here. Let's move to the next one. Transformer is used to light a 100-watt and 110-volt lamp from 220 mains. If the main current is 0.5 ampere, the efficiency of the transformer is approximately. So we have to find out efficiency of the transformer, and efficiency is output power by input power. Now output power is 100 watt. Input power is input potential times the current. So 220 multiply by 5 by 10. So that will be 100 by 110. So 10 by 11. So almost 90% is the efficiency here. Moving to the next one. The core of the transformer is laminated because ratio of the voltage to primary coil may be increased, energy loss during eddy current may be minimized, the weight of the transformer is reduced, rusting of the core may be prevented. So the main reason is energy losses needs to be minimized, because due to lamination, that eddy currents do not combine, and when they do not combine, their amplitude remains the same and they produce less heat. And their additional benefit is rusting is also preventing, that due to lamination, that iron core does not come in direct contact with air, oxygen and water, so its rusting is also prevented. Moving to the next one. A step-up transformer operate at 220 volt line and supplies current 2 ampere to the load. So we can say here primary voltage is 230 volts, secondary current is 2 ampere. Now ratio of primary to secondary winding, Np by Ns, is 1 by 25. So we have to find out current in the primary coil. So again we know that Vp by Np is equal to Vs by Ns. From this we can write Vp by Vs is equal to Np by Ns. Now Vp is 230, Vs we will find out, and that is Np by Ns, that is 1 by 25. So from this Vs is equal to 230 multiply 25. So now we will compare the power, as assuming it to be an ideal transformer. So in that case, Vs Is is equal to Vp Ip. So from this, Ip or current in the primary coil will be Vs Is by Vp. Vs is 230 into 25. Is is 2 divided by Vp is 230. Both cancels out, and Ip is 50 ampere for us. So that is option B. Let's move to the last question for this chapter. Primary winding of the transformer has 500 turns, whereas secondary has 500 or 5000. The primary is connected to primary is 20 volt 50 hertz, secondary coil will have output. So first of all, in the options, frequency is mentioned, and when flux is changed, or we can say when EMF is induced in the secondary coil, that EMF has the same frequency as of the primary. So option A is rejected, means it has 5 hertz. Actually our input supply has 50 hertz frequency, and option B is also rejected due to 500 hertz. So only C and D are possible. And for again, we know that Vs by Ns is equal to Vp by Np. From this, as we have primary and we have to calculate secondary, so secondary will be Ns Np into Vp. Ns has 5, okay, primary winding has 500 and secondary has 5000. So 5000, 500 multiply by 20, so that will be 10, and our answer will be 200 volts. So option D is the right answer here. So with this chapter is complete. Hopefully what we have covered is helpful to you and understandable also. Again, if you find this video useful, helpful, then do press the like button, share it as much as possible, and subscribe to our channel. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.